Hello everyone and welcome. In this short video, I will go through what it takes to make a video on complex things like this, like the transformer architecture from scratch. And we are going to see how to efficiently, quickly animate all of these explanations with mathstudio. Let's start with the previous things that I already explained in section 6, which is the RNN. So the viewer should know that we can model sequences with by taking inputs sequentially and processing them in a series. And we can extract at each point a different output, and we can predict the next token at each time step. This block is doing a communication between the inputs. It's doing it sequentially, and it's blocking past tokens to see future ones. Yes, tokens don't see the future. What we need is another architecture that does basically the same thing, but this should be parallel. So here we go from the RNN to the attention block, where we take all the inputs and we make keys, queries, and values. Then we make the matrix with the keys and queries multiplied together. We mask away the top right values. Then we apply softmax on all the rows and multiply by the values. This is still transforming all of the inputs in all of the outputs, which are the next tokens. It's doing communication here with the dot product of keys and values, and it's all happening in parallel. The only problem here is that this is O of n squared. So this should be our first animation, which explains why attention. Then I can probably explain what we need before and after the transformer, the transformer block to make it work. What problems attention has, so no concept of position, which we solve with the positional embeddings here, which are added to the normal embeddings to make sure that they know where they stand in the sequence. And we just use another set of embeddings that is applied to numbers from 1 to the n number of the sequence, which is very simple. Then we apply normalizations because there are lots of dot products in both attention and multi-layer perceptron, and we use a multi-layer perceptron because they are good with retaining knowledge. Attention is good with communication, MLPs are good with knowledge. We are starting out with the explanation of the attention, and we need the RNN, the picture of the RNN. Then I also want this one here with the blocks of the keys, queries, and values. The inputs can be gray boxes. Oh, this one finished. Let's see. It's kind of ugly. I don't like how they start as dots. Let's see what's happening here. I like it. I quite like it. This is fine. Move this query value table to the left. Well, first remove the arrow and move this table to the left, so that we can then move queries on top, values to the right, do the whole attention matrix thing, which is fine, which is what we want. An animation already made, which is probably here. This one. I'm copying it and moving it here. This is not being moved to the left. No. We are fixing the text, making it bigger, making these circles. In the meantime, this is the animation here, which I already made for something else. It's pretty good, but we need to add this part right here. We need to remove all the blocks in the bottom, make the whole animation a bit smaller, and add to the left and now we provide the image, which is a screenshot of this. This was pretty complex, it got it wrong, but I want to retry, and I am trying with the Pro model. This failed. Did not think this would fail. Let's do it in two steps. Instead of trying to place them correctly in some weird way, I will try to first make a table, then put them one on top, one on the left, which should work better. Okay, pretty good. Now, and we need to write these okay, queries should be to the left, values should be more right. Make the table a bit bigger. This is fine. We need to shorten the arrows so that we have more space. It really can't make this work. This is terrible. I'm trying Pro here because remember to remove it. I still have some credits, which is fine. This one here, it needs... maybe I will make another animation with the embeddings. This is why we need to go back sometimes. It's so crap at instruction following. It's crazy. Okay, I also need to get rid of the new header value. Now it's thinking about a lot of things. This is kind of what I wanted, which is fine. Okay, we are good. So we have this one here, we have this one here almost. Okay, so showing these x here and fading them out. I also have to show the softmax and the multiplication with the values, which should be doable. This one is taking a lot longer than I expected. Oh, the embeddings, which is also taking a lot longer than I would expect. Did it crash? No, this server probably hasn't crashed, but these ones are taking a long time. This should be pretty simple. Something went wrong in the API, and these ones are finished. Yes, that's exactly what happened. How it's doing? No, it's quite good actually. Scrap. Sometimes you just have to start over. It writes some code that it's absolutely unusable. It is absolutely unusable, and you have to start over. Okay, this is fine. We can write some mock values in keys and in the matrix. Remove the title. Oh, rate limit exceeded. Fuck off. Again? I tripled the rate limits. We should be fine. This one we decided we are not using. Okay. This is terrible. Yes, I've never seen something this bad. Okay. We can use this. I have no idea how to write this in a pretty way. Let's see if... this is perfect. This is exactly what I wanted. This broken in a crazy way. I don't remember. I don't even remember what I asked. We have lots of... Oh, I have the KV cache to explain. It's going to be so annoying. What do I need to write here? Communication, sequential, and tokens don't see future ones. Okay, which is... Okay, it's moving it to the right, but I wanted it left. I don't remember if I told it wrong or it's doing it wrong. It's here. It's probably fixed. This one here. It's not aligned. Rectangle. This is unacceptable. This is totally useless. Let's do it in 2 steps. These nodes are probably fine. The thing that I changed before, I asked to move it down ×2. This arrow should point right. This one should be aligned. These ones should become E1, E2, E3, etc. Decent enough. If I do 1.5, it's going to be right. This arrow is very fucked up. Let's take a nice picture. If this one works, we are basically done for the day. I'm not doing this one today. It's been an hour. It broke everything. Okay. Holy shit, it's so wrong. Okay. My god, this arrow can't be that hard. We've seen that the hidden layers of the RNN handle one-way communication. This only has one problem. It's inherently sequential. This is where we introduce the attention mechanism, with one-way communication in parallel. The first requirement is that every token should evaluate relevance of every other tokens. And the second is that each token should be updated with a weighted sum of the meaning of the other tokens. We use the relevance scores of the first point as weights. In the end, we have a vector of the same size as the input, with all of the tokens updated with a new meaning. One of the problems of the attention mechanism is the lack of positional awareness. We usually compute embedding vectors from every token, but now we also need some positional information, which we derive from another set of embeddings based on the index of the position of each token in the sequence. Attention also has another couple of problems that we need to solve. The heavy use of dot products makes the numbers quickly blow up and be unstable, so we apply layer normalizations. The other thing is that it's good for communication, but not for storing lots of knowledge. So we add multi-layer perceptrons after each attention block. This, with the layer normalizations and the multi-layer perceptron, is our unit of scale, and we use 30 to 90 of these to make big LLMs.